welcome everyone in this new episode of Let's Talk AI. I'm super happy to be here today with Anastasiia Prokaieva. Anastasia, how are you doing?
Oh, awesome. Excited.
I'm super happy to have you on the show. We have a lot to talk about. And by a lot, I mean big data. I won't start listing everything that I want to discuss with you because it will be first in the title and so on, but amazing topics that I'm super curious about. So thanks a lot for taking the time. First, maybe for the people who might not know you yet, could you introduce yourself briefly?
Yeah, sure. So, hi everyone. I'm Anastasia, passionate about data and especially AI. I've been working in data science domain for the past 8 years and also within the domain of data analytics. For the past 2 years and a half, I work at Databricks as a specialist solution architect, and I specialized on AI and GeoSpatial.
Awesome. This is very clear. I always like to ask what are people working on right now? And by that, I don't mean necessarily your actual project, but what are you like most interested in actually? What are the things that you're really curious about and like the right now for you?
Yeah,
What are you interested in and what are you doing these days?
probably what everyone is doing, Gen AI.
Uh,
Yeah, and actually regarding Gen AI, I'm very interested since the beginning of the year in actually fine tuning full pre-training of models.
mm,
So yeah, I've been really working a lot on learning and actually understanding how better fine tune and pre-train models to
mm,
actually improve the quality on the small size models.
hmm. I'll come back at you with one question later, which will be like, how do you go about proof of concepts, like building things fast? How do you think about latest news of like Google GPT-4 and so on, and then like all the open source community fine tuning models, Mistral, and comparing Mistral and Llama and so on? I think that there is a ton of value here. So I would like to ask you maybe if we could do a short retrospective, not necessarily short, but on what are the main stage of your career since university, what you've been doing. You have a very interesting career path, so I believe that we can gain a lot of value from it. Can you share
Yeah,
maybe
sure. No,
this
yeah, happy to
retrospective?
share it. So, for everyone who never met me, originally I'm coming from the domain of physics and, in particular, theoretical physics, where I've been mainly working with a lot of formulas on my whiteboard. And I've been very passionate about it. I've started studying quantum physics. I was 17 or 18, I think, at the university, and I really loved it. Actually, my favorite topic was quantum chromodynamics at the time, but the professor didn't want to take me for a bachelor degree, so I had to select something else, and it was thermonuclear physics for the new, basically this ITER build in Cadarache of France, where people try to get energy from the state of plasma, right? So after that I finished it, I've been 25, 21 years old, and I actually been proposed to do a few internships. So
Hmm.
first of all, I won an internship in Weizmann Institute of Science in Israel. So basically it's like a big competition where like out of hundreds they selected only 30 students, and that's where I've been working for 3 months for my internship, and I met a lot of cool people from Yale, Princeton, and we've been all around from world. And then the next internship was actually in France in one of the institute that's called Paris 1, so Paris 11. It's like the split of RC University. And I also been doing actually statistical analytics on particle physics.
Hmm.
And it's been very cool, but actually, I felt that I wanted a bit broader topic. As
Right.
I've been mainly specializing in nuclear physics, it's still kind of nuclear. I wanted to move forward. And actually, since high school, I've been really interested in climate change.
Hmm.
So my first research project was actually when I was 13 years old at high school. I actually studied how different, but let's say, things impacting our climate and how
Hmm.
actually we can, make things better. How can we impact it less with renewable energy?
Hmm.
And so that's why I decided to pursue a second master degree in École Polytechnique in France, where actually I've been specializing in renewable energy and technology.
Hmm.
So we studied technologies, of different things for wave systems, how get energy from oceans, from rivers. Then, of course, classic one. I've been mainly passionate, of course, about energy from water, because as I'm coming from fluid dynamics, it was something that passionate me a lot.
Hmm.
And this is where actually I decided that I want to pursue like a deeper career in research. So I
Hmm.
started working for in French it's called Commissariat d'énergie atomique, so COA. Basically, it's one of the oldest institute in France, opened by Charles de Gaulle and Marie Curie to actually work on nuclear energy. And then they start switching to, of course, bigger topics. And my
Hmm.
department was mainly working for environmental science. So our department been working for actually estimating and improving the quantification of sources and
Hmm.
things of
Hmm.
CO2 and different gases using numerical simulations and also real data. So real measured data on the Earth from ground stations, but also from satellite data. And the goal was to use the techniques that's called data assimilation to actually assimilate all of this data to improve the further forecast or the further estimate of the emissions.
Hmm.
So I've been working there for a few years. It's been like, first of all, it was a big challenge for me because I have to be very, very frank. Even though I work as a scientist and I did some data analytics, I code, but I didn't code that much, honestly, and I never really had to. And I really hated coding at some point of my life, actually. And this was the big projects that I started working. I had to code a lot of algorithms and improve models. My code was jungling between Fortran to C to Python to Bash. I've been using everything to combine together. We've been running it on like actually our own servers that COA kind of built for my team. It was impressive. I had to learn so many things. And this is where I start, meeting people, going to conferences, speaking to them. And I realized actually, want to go a bit broader. Like I wanted to be more like in a private company, maybe consultancy or something. So that's when I moved to like pure data science role, work for a small fintech in France. We've been doing also cool things, trying to incorporate all of this alternative data like GPS, satellites to actually some macroeconomical and statistical analytics to improve, the way people actually play on the financial markets. And then that's how I start working as a data scientist. I think if today you ask me what do I do, mainly at Databricks, I work as an ML engineer. So I usually do end-to-end process. So I do also data engineering job partially, then I do ML. I don't really do like data science in terms of a discovery data, but of course I understand algorithms and I can, if I need to go deeper into it. And then of course I'm putting things into production. So yeah, that's kind of about my career path.
That's very impressive, to be fair. Very impressive, and I feel that one of the main things. I mean, there are many things that we could discuss about, but the fact that you went from a researcher profile to private companies, that's very interesting. Maybe you want to comment how this felt and how being more of an academical person, due to your background and your previous experiences, how does it helps you in private companies, and maybe how working for private companies can help you being a better researchers. I don't know if there is also
Yeah,
uh,
no, I
but
think they are. Yeah,
I'm
that's at
pretty
least
sure there is.
something. Yeah,
Do you have? Yeah.
I think you actually tackled something important. So when I left science, I left it for certain things that I couldn't find in science. But
Hmm.
I also think it's because when I work in science, when you're in scientific domain, often, sadly to say, you're not growing as a personality. Okay,
Hmm.
people just see you as a brain. And I think something that I learned in a private company is actually how to grow my personality. And now, if I would go back to science, I would definitely succeed more. Why? When we are scientists, you actually have to win a lot of money for your research. Research usually has to be paid by someone, so usually you apply for a lot of competitions. You need to write a lot of papers, and you need to express your ideas in a private manner,
Hmm.
in not in a scientific manner. You need to tell people why is it important. This is something that's been missing, I think, from kind of research perspective. And if today I would move back, I'm sure I would actually enjoy it way more. First of all, so this one, right? Be more like a personality. Sorry, I go backwards from private to public, and then I would explain you how I went from public to private.
Awesome.
So the second topic that I think private actually teach you a lot, and this is also something I think that I've been doing a lot when I was a researcher, is to experiment, not to be frightened. Right? I think research helped me to actually analyze and really quickly understand ideas. So I'm able to go through various, I don't know, research papers and just really, quickly grab some ideas and start implementing those. But when I was a scientist, I was always afraid, oh, I was not sure how to implement it, because often I never had constraint of times. While you work for private, you always have constraint for times, and you need to really help iterate. So I
Mhm.
think this is something that helped me also. If I would go back to research today, is that not being afraid, go iterate, deliver on time, and just try it, like constant trial and try and trial. And at some point,
Mhm.
of course, it would make it back. So how was the transition from public and also like from research, and what did help apart from basically being able to research things? I think not giving up. This is something also that helps me a lot. When you're a research scientist, sometimes your theory may not work, and you have to be ready to accept it at some point. And I think this is also something that helps me up to today, is to be very frank with people and to say that sometimes the idea may not fit, or maybe this is just not the fit, and we need to move forward. We need to try something else. So at least for me, that was definitely something that I'm transitioning today. I think something that definitely was not enough for me when I was in research, and you actually need to do it, especially when you go to conferences, is to do public speech. So public speech was very hard at a time, actually for me, and I know no one will believe it, but when I was at the high school, I was refusing any public speech because I was so shy that I could not speak in front of anyone. So I was that terrified of speaking, even though I was playing in a theater, but playing in a theater and being in front of people speaking about some smart things, they were completely different for me. And so when I was in research, I think what I wish my research team would do more, or in general, when you're in research, is that they would also help you to go do public speech, to
Mhm.
go present your poster, go talk to some scientific people. And I had to really work hard. I was very shy going to ask some postdocs about what did they think about my ideas, can they give me any recommendation. I had to write sometimes emails after conferences to ask people, hey, can you help me to understand, because I had a question. It was very hard, actually. Like today, of course, I would not have those issues, even though I still think it's a constant fight, honestly. We always have this issue, of picking a phone and calling someone, because you're like, oh, I don't know if he will pick, or oh, what he will tell me, or she, and like, oh, maybe I will just postpone it, for tomorrow. So I think this is something that's been very hard, and I really had to work a lot, especially when I moved to Databricks. So when I was in my previous company, I didn't have customer. So I was not kind of customer facing. We had customers, but it was not my role to be often facing them.
Mhm.
Mainly I talked to my colleagues and of course to people that would face customers to explain them how this could be done. But yeah, at Databricks, if you want to transition from like pure research to some, let's say even consultancy job, right? Like if you want to be a consultant, especially in strategic consultancy, well, you will face people literally 24/7. So you have to be ready, you don't have to be afraid. You need to have sort of a stamina, or at least pretend you have it, so that people, would not actually eat you. Because the thing is that when people feel your fear, they, may just overcome you. And when you're a scientist, I think we are usually all, very nice and very chill, and we just love science. If any of you watched ever Big Bang Theory, you need to think that scientists are all different, but still kind of same. Everyone loves their stuff, they live in their small bubble, and they usually there. Some scientists, of course, are like broader. That's why someone's working for UN, maybe for European Union, and that's the type of scientists that were their personality push them further. But usually, when you are like a classic scientist and you work all your life there, as those are, as the methodology of improving your personality is not there, people usually stay more or less same, so they don't go like beyond what they are.
Hmm. That's amazing. There are a lot of insights here, and I really like. And it is very impressive also to work on those character traits. We always speak about soft skills, but
But what
the f-
are those soft skills, right? So
yes, and
they
like,
are
how do you
different.
define
I
them?
read a lot of books.
Yeah.
So again, this is also, I think, something that I would like to share with people that I've been actually learning while I've been at Databricks. So Databricks, we are all mainly customers facing. Of course, we have software engineering team, but I don't work in it. I work in what we call field department. So we are on a field and we are talking to people constantly.
Hmm.
And so we have also mentorship programs that also help me a lot. And we've been sharing a lot of insights, different books, how to understand, how to speak, how to jungle all of those situations. And
Hmm.
it's a forever pass. But if you're pursuing career, I can share with you, I've been interviewed once to enter McKinsey for a senior data scientist role. And in McKinsey, when you go to pass your interviews, you actually would have business cases. And you know what I did? I had no idea how to do business cases, and it was very hard. But for the 1 month, each night, I would go to this, preparation business case platform that everyone goes, and I would talk to random people that I never met in my life, and I would do business cases with them. And it was hard at the beginning, but after 1 month, I get better. And then I didn't pass. Like I failed the last round, which was super hard. But afterwards, when I was continue looking for a job, I get accepted to all roles I applied, including Databricks. So you see,
Mm,
I didn't enter to McKinsey, but this business case solving actually helped me to understand how to explain people what I'm working on and actually like bring this value proposition even when I was looking for a job.
mm. That's something very interesting. Like those companies have in mind McKinsey, BCG, and Bain, or like three big. Maybe you can add more, but like the way to prepare this kind of interview, it is very impressive how it can enhance, or even I think I could speak like more generally, but preparing for like high standard interviews are like very powerful to just improve basic fundamental skills that will serve us in a daily basis. And that's a very good point, and that's awesome. So so now you're at Databricks. You have this amazing background, which is filled with different kind of experiences. Um, you've worked a lot with data, so I'd like to ask you about big data. Let's say if I'm a data scientist in a little startup, and I have to do some use cases. All right, I can use Python. Like even if my company goes bigger, I'll use Spark, and I can scale that. But like when you use satellites data or like this kind of data where you have terabytes of data, how do you go about
Yeah.
doing analysis on data when you have terabytes of data or whatever you call big data to
Yeah,
start with?
exactly. So this is actually a great question. And if folks, you never use Databricks or you never seen anything about Databricks, but you, I don't know, somehow work with satellite data, I just recommend you Googling. We have so Databricks has labs. It's people internally making projects basically, and they open source, well, under Databricks license. But still, I recommend you just to go read a blog post around the lab project called Mosaic. So it's actually a geospatial project. And why I'm bringing it here. So you may also go learn about some algorithms created by BERT that's called H3 grid.
Mm,
And in reality, when we work with data, we don't have to just, take the data, throw it, and do a classic algorithm. That's not
mhm,
going to work. You often, what I tell to people, you need to architect the algorithms and you need to think of it before actually executing it. So for satellite data, usually what you do, you don't work with pixel, like
mhm,
unless it's a deep learning, but that's another story. If you want to analyze something, usually you work with aggregates. So aggregates are usually happening over grid systems, and then you usually aggregate all the time over certain domains and certain locations. So if you're able to collocate your data smart and to find back and basically filter on all of these collocations, that's where it's happening faster.
mm,
So in reality, what you do, for example, at Databricks, if you use, and I wish, I would do it that way in the past. I did it a bit differently, but today I think it's like insane. Like you gain insane amount of energy and speed. So overall, what we do is that we would try to create those grids that well, it's mathematically, let's say, equidistant grid, and we would try to collocate points from all of these grids together, and then we would recreate child and parent grids. Okay, they all connected by the id, and they equidistantly covering earth. So whatever basically id the point falls to, it always has same id. And whenever you want to recompute it, right, once computed, you always know the average. So for example, if you're working all the time with historical data, you just calculating child, parents, and once it's done, you could just go and basically retrieve the data back. So when we work with big data, there is always two things: compute and storage. Because in
mhm,
reality, when you compute, you don't actually put everything from storage to the memory. That's the way
mhm,
Spark works, right? So
mhm,
he reads it, kind of partially with partitions, with portions of data and chunks to actually to memory, then treats them and then sends the results back. This
Mhm.
is where sometimes your algorithm may not be fixed for it, by the way, and you will have to write a new one, and that you need to also accept it. Or you may mix some algorithms with something else, and this is also, I think, a big challenge, because today often when I meet people, they tell me, oh, how can I run this library on Spark? Well, you can't, because it doesn't exist. So or
Right.
you write it yourself, or you find a way how actually, modify your data and try to distribute it according to some maybe groups or segments. And I'm always telling people that sometimes keeping data, vertically rather than horizontally makes more sense for you than actually doing what you do today. So, I think it's very different mindset, and it's also something I learned a lot when I joined Databricks. I had something of it in sort of like naturally coming to my head, because before coming to Databricks, I already started using Spark and Dusk. That's
Mhm.
basically two kind of big competitors, but Dusk is sort of, I don't want to say dying, but it's not that popular today. And
Mhm.
also didn't grow into that big ecosystem, but they work on similar ideas. You have a schema, and then the batch of data would come, being analyzed, and then processed, because you would not analyze anyway all of these terabytes at one time. It's usually never the use case. At least it's not common usually.
Mhm.
So the next approach is usually when you don't work with satellite data, but maybe just tabular data. Do you really
Mhm.
need all the data? Like, do you even need it? This is usually the question I ask people. Great example. I really love to give it for people. Of course, some data scientists may go and judge me, but I think it also helps for some people to project. So I've been working for a cybersecurity project, and they actually had 2 terabyte of data. But the thing is that we wanted to, well, detect something, classification problem, say it. We didn't had labels for 2 terabytes of data, and of course we would never do it. So we actually mixed some open source labels with something that we could make, and I ended up of having, I don't know, 300,000 lines. So of course I train a model, and like basic model, I don't know, XGBoost, and I tune it, etc. So model is there, and it's a scikit-learn or XGBoost model, and then I have 2 terabytes. So you still need to apply it. So again, thanks to Spark and Delta, you can just serialize everything from MLflow and just apply it to big data. And of course, not everything was great, but the results were still like overperforming the statistical things they did with SQL before. So this is also right. Think of what you will gain by improving at least for 5% or for 2% rather than not doing anything at all. Just because it doesn't fit doesn't mean that you need to give up. You can find a solution that improves a little bit, and then you kind of approach your target with different steps, because sometimes you cannot be A and go to Z with one jump. It's usually not never happening, and you need to go it step by step with everything, work, life, so that's basically how I approach big data, step by step.
I like how you started by big data and ended up like generalizing an axiom for life. Awesome. Maybe if I push a little bit on this just to have further information, so I understand clearly how you approach, and I believe that each point are valuable. How about for say you want to do deep learning?
Mhm.
So deep learning, and so sometimes you'll be able to remove, let's say, like you don't need all the data, or you can
Yeah,
take a
no, for deep
sample.
learning, it's a bit different. So, okay, let's take 2 examples. You want to do some statistical average from satellite data, and then you actually want to use some data to actually do deep learning, maybe to learn some patterns. So first of all, when you do statistical analytics, if you need to, I don't know, let's say you want to get average about France, and then you want to get average about Italy, Spain, it's a pretty big chunk of data. It's not going to be
Hmm.
one image. It's usually going to be multiple. And if it's over the year, then
Hmm.
you would get actually like really like gigabytes of data inside memory.
Hmm.
While for deep learning, usually you don't actually through all data at once. You would actually through them in batch. And that's why there is data loaders for different algorithms that actually help you to just grab the chunk of data and like naturally actually distribute them. So today in deep learning, when we do training, we usually use distributed data parallel. So it's
Hmm.
basically when you not copying data all around for different workers, but actually you would send different chunks of this data and then train. And today, even going further, it's if it's not deep learning, but let's say Gen AI are very big models versus deep learning when they're small but a lot of data, and Gen AI it's usually huge model, a bit of data. And then for Gen AI, you would go FSDP when you actually can split the weights, the model, itself, the optimizer, and then they would actually kind of average all of this. So just two different approaches. So for deep learning, usually I recommend first, you scale up as much GPU you can fit to one machine. Usually you can go today up to 8. And again, better instance you using, because something that I think I have a lot of fights with like all deep learning folks that did it on prem, we all can buy GPU today. Like it's not that expensive. It's still expensive, but in my previous company we had GPU, and a lot of people just like say, "Hey, I buy a GPU for many K and I have it." Right? Your Mac has it. So the thing is that GPUs are different, and if you are training anything, you probably would use different what we call precision. And all GPUs don't have good precision. They just bad. So this is first. So don't economize your money. Use a nice GPU, because better GPU brings you efforts. People actually working on making those GPUs more and more powerful by writing better optimizers for them, like NVIDIA and AMD. So don't hesitate to go to 810, 800, or even, like 800 today. We get in access. Of course, then there's TPU, but it's only when you're using Google. So that's where we have more issues with it. But let's focus on the GPU size. So once you scaled up and you don't have bigger GPU and it's still not enough, of course, then you would start scaling horizontally, right? And then usually I never recommend people to go horizontally if they have bigger cluster or bigger instance. If you can get a bigger instance with 4 GPU and it fits, if it's go too slow, then okay, yeah, we could of course go and accelerate it, add more nodes in a distributed fashion, and use those DDP algorithms to actually make it. And again, Spark works there. So Databricks, we use in Spark to distribute it. So there are a lot of algorithms, and I think what is the most complicated and where you need to pay attention when you're doing deep learning versus just calculating statistics for satellite data is how systems are connected, meaning your network between your instances. If you have more than one, how are they connected? Are you using actually the machines that are connected better? And this is actually on your cloud provider. So if it's your own instance, I doubt they are properly connected, and you may not even have latest CUDA library. So that's where again I'm like very big opt for cloud providers, especially when it's coming for GPU, just because I've been there and I've been setting my own GPU libraries, and I've been struggling with making all the time Docker containers and trying to connect those two GPUs together because they would never distribute me anything.
Mhm.
So I think today companies that offering you to like have things that are set and you don't need to install anything, that's definitely helps a lot. So yeah.
Awesome. There are many things that I really like about what you just said, and also earlier in the episode. So you're really able to take any project from no data to scaling up resources and having the ecosystems ready to receive, and then work on the use cases and the problem, and add value and deliver this value, communicating it in an efficient way. And this is very impressive, because I believe that we are still seeing like some people who are very focused in data engineer, other in data science, and in those two fields there are already like a whole world of people who are like specialized in things and so on. And that's very interesting how you're capable of just moving. So first question is like how do you see, so like there is this paper or articles like the AI engineer, there is also ML engineer which like go to production. How do you see yourself in the field, and how do you see the roles that will shape the future of data AI?
Hmm. Yeah, that's a good question because it's actually moving very quick. Now
Too
there's like
fast.
this prompt engineers, and
Yeah.
it didn't exist like just before. So I think it's also more about what people want to do. I think we are really lacking very good data scientists that are really know how to work with data. Like looking for patterns, for features. But then I don't think we need that many. We just need a very good one. But then once it's found, they still need to do something usually from time to time. So I think we definitely requiring to have more ML engineers in general, people that can do from end to end. It's very important. And we also requiring to have people that really know how to productionize, not just dockerizing. Because
Mm-hmm.
you know, dockerizing, it's one, but when you want to scale, I'm not sure that Docker scale, like, well, I'm not sure. It's not scales that straightforward, you know, and people, of course, then move into Kubernetes, but it
Yeah.
still may not scale and you might not be proficient with it. So
Mm-hmm.
I think so I think looking at myself, I probably could do anything,
Mm-hmm.
okay, but the quality of it may not be as good as professional people would do it that are
Mm-hmm.
specialized in it. I think it's important if you want to be a data scientist to still know data engineering. And if you want to be ML engineer, you're obliged to know data engineering. Okay, so it's not like I may know data engineering. You cannot do any productionizing if you don't know data engineering. At least
Mm-hmm.
like a good background of data engineering. You
Mm-hmm.
may not be like super skilled in Scala or like I don't know maybe Kafka or stuff like this, but you still need to know components and to understand the streaming, batch, and real time inference. Because
Mm-hmm.
well, if you don't, then that's already an issue, right? How to productionize it. Regarding the future, I think it really will depend, if the community today will accept that AI, like Gen AI, will be shaped further and they will go back to this era when we had deep learning researchers in companies and they will
Mm-hmm.
need people to train those models for them, then of course we will gain better, more like research positions. But I really think we require still a lot of data engineers. Sadly to say, when I was looking for a job, a lot of data science roles and data engineering roles, they were just analytic roles. Like you just do some SQL tables. And honestly, I'm horrible in SQL. And I think people that know SQL, they are great. Like I use PySpark all the time. And when I can do SQL, I do SQL. When I can avoid SQL, I'm like, no SQL. Please, no SQL. I don't know, never had love for SQL because it was not my primary language. And of course, I use it, but I'm just not a fan. Some people love it. But the issue is that sometimes when you look for a job, your company will not distinguish. They just want someone to go to look at the data and do something for them.
Mm-hmm.
So I think what I see that is missing today is that when people do data engineering, they have no idea about ML, like at all. Whenever there is a word AI, they're like, oh, that's not mine. Hey, data scientist, go deal with it. This is an issue for me. I think people need to have broader spectrum. In general, you need to be more versatile. So you don't have to say, oh, I don't need to know cloud because I'm a data scientist. Who cares about VPC networks and like what is the router, all of these things.
Mm-hmm.
So you don't have to be like super special, but to knowing basics and understanding how the infrastructure works
Mm-hmm.
definitely will help you to go forward, of your career. If you go being a research scientist, there are a lot of great research scientists that do very great research, but then you need to focus on pure algorithmic skills on testing because when you're a researcher in a big company or in a serious company, researchers still do ML engineering. They still need to test their code. A lot of folks that work at Databricks for software engineers, they are ex-researchers and they actually start making ML flow, and then they are Databricks software engineers, but they are ex-researchers. So I think you cannot be only one. I don't believe into it, honestly. I don't think you can be only one. Your job, whatever you do, always touch in some other domains. Of course, you don't have to be like expert in all of them, but you need to be like just broader. You need to have interest and you need to just cover them. So I think the future will go that we may stop even calling this data scientist ML engineer, and people may just have, like what it was before, data architect, research scientist, and then, DevOps. And that's three jobs. And then each company will call them the way they want. Just read the description, talk to the company, understand what they want. I give you a great example. I remember someone was talking to me. They were looking for, I don't remember if it was data platform architect or data engineer. Probably was written data engineer. And when then they start talking to me, oh yeah, we want to migrate to cloud from prem, or we have those issues. We don't know how to support too many systems. And I asked them, so you're looking for someone who can deploy it with Terraform, right? And they were like, what is Terraform? I was like, okay, yeah, infrastructure is a kind of like, oh no, tell us more. And after we stopped talking, they were like, oh, so do you want to come work for us? You seems to know so much. I was like, well, no, because I'm not an expert in it. I just know it because, well, I'm using it. I'm like a user, but I'm not an expert. But so this is the gap, right, between being a user and being an expert. I think I'm a
Mm-hmm.
user of a lot of things. I definitely expert in what I need, and maybe not, but you have to understand that you need to know more in general, right? Because
Mm.
this is the way. today. So
Mm. And by doing
what do
so,
you think?
this is how you define in what you want to be an expert, I guess, like by being a user of many things and you know what you want to really
Yeah.
study it deeper. uh awesome, very interesting. I'd like to go on Gen AI,
Mhm.
because I've heard it's
A hype topic.
something that people do lately. That, by the way, when I hear AI lately, I try to use this word cautiously, just because I feel like we associate too much of the hype of Gen AI with what's AI.
Yeah.
And I like, this is not me, but I like people who talk about good old AI, where we just do neural networks or just basic fundamental things. So coming back to Gen AI, how do you see? Maybe you can share about your experience with it, how you got introduced to it, and also like what is the value from your perspective. Like I said in the beginning, I have a feeling that people go to GPT 3.5 or 4 to like just test things fast, and afterwards comes the I'm going to fine tune the model. I'm going to use open source. I'm going to use Llama, Mistral, based on the specific things that I want to program or to do. So, how do you see Gen AI lately? And do you have insights for us?
So I will start with a very funny story. How I actually kind of used my first, LM model,
Mm-hmm.
large model.
Yeah.
So it was in 2020, I think. I worked still in my previous company. And we had an intern that today actually work at Google. So, well, I hope his internship went well. So, and he was working on a project trying to analyze tweeters, sentiment from tweeters. And
Mm.
I remember he was like, "Hey, I found this model called BERT." And so he
Yeah.
made us a presentation about it. And I was looking at it, I'm like, still was transitioning from science. I didn't understand anything he tried to explain. I was like, I don't believe it can work. I look at it, at the way he explained it, was like, 100% it's fake. He faked it somewhere, but I didn't have time to go deeper into it. And I was like, definitely fake. I look at this transformer and I was like, what the hell is this doing? Like, I don't believe it. So that was the way I met BERT model in 2019. So coming back, actually, how I went back and how I actually deep dive into transformers and how did it started. So I think it was around year and a half before actually GPT kind of rock start. Hugging Face was going back. So we've been seeing more and more applications from our customers. Again, as I'm attached a lot to customers, usually I'm following trends. Of course, I'm checking LinkedIn, blog posts, podcasts. So people were going back talking about this cool stuff called Hugging Face and like these transformers. And I was like, oh yeah, it was that model. I remember BERT. And so I went into and I was like, hell, I don't really understand how it works. So, let's deep dive. So overall, I purchased this book. It was in preview from Hugging Face called Natural Language Processing with Transformers. And then I also went and looked for some blog posts that people were doing. So I did the hard way, I coded Transformer myself because I
Mm.
really wanted to understand it. I went through all
Mm-hmm.
math. I really understand how all of this works because that was my goal. I really
Mm-hmm.
wanted to prove myself and I understand everything. And so then my colleagues start asking, like, hey, I heard there's this cool stuff, Hugging Face. I don't know, do you know about it? So what I did is that actually we did workshops. So I read the book and I actually explained to people, first of all, basics of deep learning, like very quick if they don't know at all, like because you still need to know something to understand. Then explain them the basic of transformers, what is the encoder, the decoder, and basically how those model works. And this is when we actually started working with customers. So we didn't use, like, we really seen it before GPT. Like, so when people tell me, oh, everything started just because of chat GPT, it's accelerated it, meaning it brought it faster to other companies. But other companies knew about it. BERT, like BERT, was used in finance for like since 2019 or
Mm-hmm.
20 when they published the weights. And I remember everyone were like secretly saying, oh, do you have these weights? Oh, send me these weights because I need it. I want to fine tune my own model. Today, fine tuning BERT sounds like, oh, fine tuning BERT that like, I don't know, I just need labels and it takes me like an hour. So this is how actually I started. What is my point of view is that, as you said today, I think everyone just doing it for hype. They don't try to understand how this can really change things in their company. And this can actually change things in their company. I think that GPT is a great model for doing what it does, meaning generating things. But, there's but. GPT doesn't have, like, he doesn't have knowledge. It's not intelligent. Okay, let's be very frank. And some people asking me, oh, it does math so bad. Like, why it does math so bad? Well, because it doesn't have brain. It just has some logic. It's a probability, generating probability of a sequence.
Mhm.
So if he didn't learn it, there is not really a lot of chance he would kind of generate you a good probability of it. So you or teach him yourself, and then he kind of mimics you. So for me, we actually have seen a lot of great applications, not using GPT, but just using classic, like language models, not like large language models, like X large language models for sentiment, for zero shot extraction, for entity recognition. Most of the time, when you want to combine them all, right, you want to fine tune them. And we saw great results. I literally had customers migrating from cognitive services where they had to pay to make labels, fine tune their own models, economizing hell of money and owning it, and going faster to production because, well, now they're owning it and results are better and business was happy and they even saved money. So, when you tell to business, we make it better and we save money just by spending 2 weeks making labels, most of people accepts it. So, what are will be the future? I'm sure now companies finally realizing they are a moment. Not sure they really realizing where is the moment. So
Mhm.
it's also for people like us, who works with those people, to bring new use cases, to build more examples. At Databricks, we call it solution accelerators that we build in and show into customers and our partners. To explore more, I really think we're just in the beginning because, I recently read they finally start using transformers to improve meteorological forecasting. And Transformers been there since 2017. Hey, 2023, we are 6 years delayed. So I'm really looking forward. This new model from company Mistral that are French. Again, very super excited. Folks from Google, Meta, everywhere left places where they maybe didn't feel any more personals, and they decided to make their own things. And they made a new model for a mixture of experts. Then this new Gemini model that's multimodal. For people that don't know what is multimodal, overall, it's when you can put the image and the text and it works same time, because normally that's not the way models should work because they usually learn in something one, how to work with text and how to mimic your text and your speech. Um, so I think those models, again, for me, main use cases, sadly, I see today is just to mimic human, which is okay. But do you really need to pay, or do you, environmentally speaking, do you need a model for 500 plus billion parameters to mimic yourself, right?
Mm.
So I think it will come. I really believe those models will go smaller and smaller. Also, fine tuning is getting cheaper and cheaper, and pre training as well. It doesn't cost anymore what it used to cost. A lot of companies today that say, I don't know, you're a marketing company and you want to help your customers make better marketing campaigns, but speaking just for your customer. Say, I don't know, you're a luxury company. You cannot use the same model as the company that sells, I don't know, like day-to-day sport clothes. It just makes zero sense. Your audience is different. People speak different language. So the model, if you use one model for both of them, probably you would have something average. But if you would have a particular model for them separately, that's where you may see actually results. And again, I think it's debating. Some people would say, hey, fine tuning doesn't really work. So I think you really need to understand how to fine tune and what do you want to fine tune, because we
Mm.
saw great improvement. And the next step is that you don't always have to fine tune a GPT-4 model style. You can actually have a lot of tiny models that would cover for it. So for me, I think I'm really looking forward to improvement around orchestration,
Mm.
Llama Index, LangChain, other companies, also for evaluated models. I think something we didn't touch,
Yeah.
but this is actually coming very complicated with Gen AI. How to interpret or how to control them, how to evaluate them.
Mhm.
I think in general it's missing. There are some companies and some open source projects that's been in general evaluating models,
Yeah.
like deep learning models or classical ML, but we didn't really move forward. And I think it's been like since I start working on the market, nothing almost changed, for being very frank. For
Mhm.
6 years, no progress because people are okay with what they have, but no one tries to, figure out something better for this. So I really hope it will get better. Who knows who will come up with what? But recently there was this new publication about the purple llama, the new basically frameworks that helps you to control your models, to verify them, how to be sure a model, like you cannot kind of hack a prompt model. Because I think, when I talk to some people, they're like, oh yeah, we will use whatever is simpler. Yeah, it will work for probably like a few weeks or maybe a few months, but once someone make a hack of your prompt and they go and judge your company on an international scale, this will stop working. And I think this is where we are not yet, because and it's just been like what, few days ago, the new European AI Act, right? And this will go forward. So what I also looking forward is for this data to represent people, to have less biased data so that companies would really take care of it and we would actually know what they used for this data. Because frankly
Mhm.
speaking, yeah, it's a bit, yeah, warning. And maybe I'm also taking it a bit cautiously because I don't know, which type of data is used. And I'm also a person, right? Even though I work for IT company, but I still a person and I still live. So yeah, it's also something that probably kind of tickling and like saying like, okay, it's ringing the bell, which data they use. So looking forward also for kind of some transparency. And of course, the last, not the least, it's environment. How much energy do we spend for using it? Is it worth it? Is it really bringing any value? Can we make it better? Can this GPT run or whatever model you use on some renewable energy? Or I think some companies moving great towards, reusing plastic, reusing paper, using alternative energy. And I really hope that it would be accelerated in general. So
Hmm. That's amazing. You said so many things. I have too many questions. We don't have enough time. Yeah. um, Super interesting. You're right. We could have discussed further the how to evaluate models. There are this, like you mentioned, it is very cheap nowadays to like fine tune models. A lot of people are working on these things. A lot of people in the open source community are sharing a ton of things on this. I think that we can fine tune some models for around like with like resources in the cloud. Like for $100, we can start fine tuning models and so on. So that's awesome. You mentioned evaluation. Uh, I feel that the main go-to right now, correct me, is comparing it to the strongest model. So maybe
yeah,
GPT-4
to
right
the
now.
judge model. That's basically what. So at Databricks, we actually made a research. So it's been like some people from field and engineering team, and there's also a lot of research. So of course, we based ourselves on something.
Mm,
So I think so far, so the way I'm using it and the way I see it is that you cannot evaluate everything yourself because it's really a burden, and it's like physically complicated. And this model, as they actually train to mimic the language, mimic what you would think by reading the text,
mm,
they are actually good in re-evaluating if you give them a task. So if you tell
mhm,
to the model, this is like sort of the tasks I want you to evaluate this text on, I really
mhm,
think this is smart and it's like really working, but you just need to give a task properly.
mm.
So I think it will move forward. Like we just like at the beginning, I don't remember
Yeah.
who said it. Probably it was Andrei Karpati, who is the creator and the. I think he said that for him we are like at the beginning of computers, just after
Yeah.
calculators, And
Mhm,
I really believe it. I hope, because if you look actually at the past, I remember at the past deep learning was super hyped and then it died. Actually, it's something that I learned a lot when I joined Databricks. There is this company called Gartner and they have this cycle.
yeah.
So and they basically project when they're going to be peak, when they're going to be a throw, and then when it's going to stabilize. So let's see what it goes. I don't know if we are on a peak or we move into the peak, but probably the greatest achievements will happen after we drop. because that's usually when everything, when people really start, thinking what they're doing, and then we probably, hopefully, will go to plateau, or maybe there will be, especially for multimodal models. Look, I don't know, let's see, but I'm really looking forward to it. I just wanted to share, for example, what we did at Databricks, and the way, for example, Databricks help us to accelerate. So we have this stuff that basically it's a bit like a chatbot that learn from all our internal data. So it's a Confluence, Jira, Slack, and everything, and also
Hmm.
Docs that we have. And then you can just type, keyword search, and basically it would bring you more documents. And now we actually introducing a Gen AI model that even could summarize you certain of them. So the thing is that Databricks, they actually have hell of documentation. And I know
Yeah.
people may not realize it, but I used to spend hours to go look through the list of presentation and documents that I had. And just when they bring us this, simple tool that would pick me them like everything that matched my keyword search, it literally saved me probably at least 30 to 40% of my work time. Then we moving forward. For example, we also creating a bot where you could type also some products of Databricks, and it would actually bring you all the blogs, all the videos, and everything that's been mentioned in this, with also exact minute for the cut, because we also analyze the description. And then it would kind of combine you it in an email so that the sales team could sell it, could send it
Hmm.
back.
Hmm.
Or even myself, when I talk to customers, they ask for links, and usually it's a manual search. Just go back and look for all of these
Hmm.
blog posts. So this is something even we bring into our company, right? And you've been bringing it for a very long time. So those simple use cases can really accelerate, your company for like 30, 40%. So I just really hope that this technology would really help, to make our life better.
Hmm.
Because I know some people, I fear they have fear that this may replace them, right? So I honestly don't see right now that it's kind of really replacing people. I
Hmm.
see that it's actually helping and accelerating your work. And finally, you could actually remove some not really, let's say, task that you're not supposed to do at all, and do
Yeah.
something better, like
Yeah.
just focus on the real job rather than like doing repetitive tasks. So
Hmm.
for me, I see it as acceleration, and I really hope that all companies will focus on it as acceleration instead of replacing people, because I don't really see it replacing people. If someone sees it, happy to talk with them and debate, but that's at least my vision. Maybe I'm too over positive, but I don't think that it's possible today to replace human just the way we are.
Hmm. Awesome. I love it. Yeah, I would have many questions. We could go into agents, swarm agents. Those are very interesting. I really like how you've like put it in perspective. What I really like particularly is that yes, we're going to be able to do amazing things. As of now, I believe that the main value that these tools gives are around summarization and retrieval, and combining these two tool with automation which already existed, but now we can automate things on a higher level maybe. So very interesting. I'm sure there are more, but this is what I have in mind.
Yeah,
um
I think a use case that I like to give, you said summarization and retrieval.
mhm,
Think of, you have legal team. They have a lot of documents, and they just want to find all the documents. They ask a question: show me all the documents with a contract with Databricks that end in March.
yeah.
But if you think of it, how do you do it, right? Is it a
Mhm,
chatbot? Is it a retrieval Q&A? What is it?
yeah. Mm,
So very classical use case. And I think for this one, we had a lot of, or another one. Say you're a company and you really care what are inside some products that produced in different countries. You're an international company, and you just want some people go make photos, and the application would automatically scan and say, if it's good product or not,
yeah.
or maybe even tell you, oh, by the way, this is like above the norm and stuff like this. So it's existed, but it used different technology.
Mhm,
So it doesn't mean it didn't exist. It may existed, but it may be done manually, or like not in
mhm,
a very efficient way, and you made to wait hours. So I think where I really see it, and I really hope we will be there, is that these transformers, okay, not like Gen AI, but transformers algorithm could help us to see data with new patterns or identify new patterns, not just in text, but
Yeah.
in anything, maybe in some patterns for medical studies, patterns maybe of creating musics, of mixing colors, time series.
Yeah.
General, the technology is very interesting, so let's see how it evolves. But I mean, it seems that it looks for proper patterns, so I think we should just work further to explore more domains,
Yeah.
and yeah, probably GPT style things would be everywhere. We just would use the technology under the hood that are transformers, and they will be different, and it would just be applied to maybe even soon to classical ML. Let's see, who knows.
Mhm. I also believe that. Awesome. Well, I have two more questions, and I had an amazing time. Those are like two closing questions that are about yourself. But before, thanks a lot for coming on the show and sharing. I learned a ton, so I want to thank you for that. The first one is, where can people learn more about you and what you do? Is it on LinkedIn? Do you have a website? Like, what do you have going on?
Yeah, so I'm probably not a very public person, even though, well, maybe it's a good time to become. So yeah, I have a LinkedIn. So follow me on LinkedIn. You can always write me. I'm pretty friendly. Also, as working at Databricks, we're running a lot of public events. Like we're running Lake House Day. As a base
Yeah.
in France, mainly it's in France, but sometimes we travel to other countries. So pass by, they all free. Just register, follow up, pass by, say hi, ask your questions. We are always open and friendly. And we also have a small YouTube channel where we posted mainly a few videos. They are mainly on CI/CD because I've really had a feeling people struggle to do CI/CD. So we posted some. But yeah, just subscribe on LinkedIn and let me know if you think you want to hear something more about. So I don't know, may think of it and make more content.
Awesome. And last question, would you have a message for the Let's Talk AI community? It can be anything that we discussed in this episode or something totally new, personally, professionally, whatever you want.
Yeah. So I think my message would be, don't be afraid. Accept the challenge and move to your goals, because if you put your hands down, nothing will change. And I think for me, this definitely worked. And trust me, I had upsides and downs a lot in my career path, but it's all turned out being super cool. I'm super excited talking to Thomas today, and you could also do it. So just, yeah, keep moving and yeah, enjoy using AI.
Awesome. I wish you to have a wonderful day.
Yeah, you too.